1 all over 64 raised to power 1 over 2 divided by, now we are dividing, 1 all over 32 raised to power 2 over 5, which is equals to 27 raised to power 2 over 3 times 1 over 64 raised to power 1 over 2 times 32 raised to power 2 over 5 over 1. So we now move here. So we now find the cube root of this raised to power 2, find the square root of this, we find the fifth root of 32 raised to power 2. So we'll now break it down to something like this: 27 3 root 27 all over everything raised to power 2. Then you can see, then times 1 all over 64, that is square root of 64, everything raised to power 1. Anything raised to power 1 will still give us 1, will still give us back the number, times 5 root of 32, everything raised to power this 2. We are applying indices, law of indices, number 6 and 7, and then I think that's number 5 for this minus. Now we're having some 3 root 27 will give us 3 squared. Then this one, square root of 64 is 8. That will be 8 raised to power 1 is still 8 times 5 root 32 is 2. That is 2 times 2 times 2 times 2 times 2 will give us 32. So we're having 1 over 2 squared. So we will now be having something like this. That will be 9 over 1 times 1 over 8. Oh, sorry, this ought to be 2 squared. This all over 1. Now we'll be having times 4 over 1. 4 divided by 4 is 1. 8 divided by 4 is 2. So we'll be having 9 times 1 times 1, that's 9. 1 times 2 times 1, that's 2. So which is equal to 4 whole number 1 over 2. Example number 16. Simplify 4 raised to power minus 1 over 2 times 16 raised to power 3 over 4, all divided by 4 raised to power 1 over 2. The first thing you have to do is you have to resolve this minus, which will give us something of this format: 1 over 4 raised to power 1 over 2 times 16 raised to power 3 over 4, all divided by 4 whole number 1 over 2, which can be written as 1 over 4 raised to power 1 over 2 times 16 over 1, 16 raised to power 3 over 4, divided by, this 4 is just like 4 over 1. So we'll now be having 4 raised to power 1 over 2 over 1, which is the same thing as 1 over 4 raised to power 1 over 2 times 16 raised to power 3 over 4 times 1 whole number 1 over 4 raised to power 1 over 2. So what we'll now be having here is 1 over the square root of 4 raised to power 1 times 4 root 16 all over every 3 raised to the power 3 times 1 all over 4, that is the square root of this, all raised to the power 9. So from this, from what we are having here, we are having something like this. The square root of 4 is 2. 1 over 2 raised to the power 1. This 4 root 16 is 2. That will be times this all over 1 times 2 raised to the power 3 all over 1 times what we are having here, square root of 4 is 2. So we are having 1 all over 2 raised to the power 1. So what we are having is 1 all over 2 times 8 all over 1 times 1 all over 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 2 divided by 2 is 1. And then 4 divided by 2 is 2. So our final answer is 2. 1 times 2 times 1, that's 2. Then 1 times 1 times 1 is equal to 2 all over 1. So we can conveniently say that our final answer is 2. Example number 17. Simplify 8 raised to the power 1 over 3 times 25 raised to the power 1 over 2 times 8 raised to the power 0. Here we'll be applying law of units number 3 and 6. Law number 3 says that anything raised to the power 0 will give us 1. And then for this, for law number 6, says that any 1 all over 3, that is this 3, this our denominator is our root. We'll use it in getting our root, and the 1 is just our power. So we'll be having 3 root 8, everything raised to the power 1, times 2 root 25, everything raised to the power 1 times 1. 3 root 8 is 2. That is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Times 2 root 25 is 5. 5 times 5 is 25 times 1. So this will be equal to 8 raised to the power 0 is 1 from law 3. 2 times 5 times 1 is 10, which is our final answer. Example number 18. Simplify 64 raised to the power 1 over 2 times 9 raised to the power 3 over 2 times 2 raised to the power minus 5. Here we'll be applying law number 6, sixth law of indices, according to what we have in while explaining. And then we'll be applying the 7th law of indices and then the 4th law of indices. Now, what we're having here is applying the 6th law of indices to this, we'll be having 2 root 64 raised to the power 1. Applying the 7th law, we'll be having 2 root 9 all over 3. Applying the 4th law, we'll be having 1 over 2 raised to the power 4. And 2 raised to the power 5. So 2 raised to 64 is 8. That is square root of 64 is 8 raised to the power 1 times square root of 9 is 3 raised to the power 3 times 1 raised to the power. Then 2 raised to the power 5 is 32. That is 2 times 2. 2 times. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So what we'll now be having will now be 8 times 27 times 1 over 32. Which is equals to 8 divided by 8 is 1, 32 divided by 8 is 4. Now we are having 27 all over 4, which is equals to, which is also equals to 6 whole number 3 all over 4. Example number 19. Evaluate 27 raised to power 1 over 3 all over 16 raised to power minus 1 over 4. The first thing we have to do is we have to resolve this minus. So this will be equals to 27 raised to power 1 over 3 divided by 1 over 16. Mind you, these are numerator, this is 1 over 4, which is equals to 27 raised to 1 over 3 all over 1 divided by 1 all over 16 and 1 over 4. By the time we are changing this sign to multiplication, our denominator will become numerator. So we'll be having something like this: 27 raised to 1 over 3 times 16 all over raised to power 1 over 4. This over 1, this over 1. So we will now be having something like this. Applying the sixth law of indices, this will become